Okay, now let's learn about the phenomenon of photoelectric effect. Okay, also based on Einstein's photoelectric equations. Okay, which is E equal to K max plus work function. Okay, first thing you have to know is okay, we already learned that one photon, which is also called one particle of light. Okay, want to emphasize again, photon is actually a particle of light. Yeah, one photon means one particle of light. Okay, light has many particles. Yeah, we learn the light in the form of particle, not in the form of wave. Yeah. So light has many particles. This is the light, and photon is the particle. Each particle of light is called photon. Okay, one particle of light or one particle of light or one photon. Actually, this is not just the light. It can be any electromagnetic radiation. Not just the visible light we see. It can be any like X-ray, gamma ray. They are also called the electromagnetic radiation. They also have photon. All right. X-ray also have photon. Microwave, radio wave also have their own photon. Okay. Don't just limit to the visible light with color, red, blue, the visible light that we see. Those wave that we cannot see, those waves we cannot see like radio wave, they are also have photon. They also have photons. They also have their own particle. Okay, they have their own particle. Okay, one photon only eject one electron. It won't eject two electron, and also electron won't receive more than one photon. Okay, remember the spelling is photon. P-H-O-T-O-N. It's not proton. Proton is the positive charge. It's not that. It's not the proton in the nucleus. Photon is the particle of light. The particle, the light or the electromagnetic radiation particle. Light is a light particle. Okay, it's not the proton. Okay. So one photon only eject one electron. It won't eject more than one. It only eject one electron. And sometimes can eject the electron, sometimes cannot eject the electron. It's just the matter of can or cannot. Okay. How to know whether can or cannot eject the electron? Later we will see. Okay. The electron will receive all the photon energy. Okay. That means one photon has the energy of HF, and the electron will receive all the energy HF into the electron. That means the electron will absorb the whole energy from the photon, entirely. Okay. So this whole energy will receive by the electron. It receive all the HF energy. If that means, if let's say the energy of the photon is 10 joule, the electron will absorb all 10 joule. But 10 joule is too big a number. It's not 10 joule. This is just an assumption. Okay. This electron will absorb all the energy from the photon. Okay. Now let's look at whether can or cannot eject the electron. Once the electron is ejected, it is called photoelectron. Photoelectron. That means we can say the photon and electron combined lah. Or we can say electron has already absorbed all the energy from the photon. Ejected, become a photoelectron. Okay, why is it ejected? Because of photon, you receive the photon. That's why the name is itself called photoelectron. Okay. It ejects from the metal surface with the help of the photon. Now, let's look at this one. Okay, first of all, this one, the first example, we have three conditions. The first condition is the HF more than the work function. Actually, we learned this before in the photoelectric equation. Whether how can eject or cannot eject. Can eject is the incident ray, yeah, the incident photon must more than the minimum energy or more than the work function, then can eject. Or we can say the incident frequency must bigger than the minimum frequency, or we call threshold frequency, then only can eject. The wavelength need to be smaller than the maximum wavelength, or we call threshold wavelength, before it can be ejected. How to prove that? We already show by the formula, isn't it? E less than work function. Okay, you see from here I can get incident frequency more than the threshold frequency, incident wavelength less than the maximum threshold wavelength. All this can be ejected. If the other way around, then cannot eject lah. Okay, let's look again. So this is the incident photon energy. This is actually HF is the incident photon energy. Okay, more than the work function. Work function is the minimum energy required. So if the we can see from this equation, you see this one, like this one, you see, E is the incident photon. Yeah, we can go back to here. Yeah, see this one. What is E? E is the energy of incident photon. K is the maximum kinetic energy after ejected, and W naught is the work function of metal surface or the binding energy. So let's look at this one. Okay, actually we can let's look again. This one, you see, this is the energy of incident photon. W naught is the work function or the binding energy, and this is the kinetic energy or the remaining energy after ejected. So we can say that the energy of incident photon need to overcome the minimum energy, or we call the work function. Yeah, we can write this as the work function is actually the minimum energy required. Minimum energy required to eject, or the binding energy. If this incident photon energy more than the minimum energy, then it can eject with kinetic energy. It's just like this simple example I make here. You see the cartoon here. Let's say you want to go for a concert, sing by the Ash, and I don't know what's the name of this fella. Okay, singer and a dancer. Okay, so if let's say the concert, the entrance ticket is 50 ringgit to enter the concert, the 50 ringgit. So your mommy give you 100 ringgit. 100 ringgit. So can you afford to go into the concert? Of course you can, because we can say the money your mommy give you, or that your dad give you, is the energy of the incident photon. Energy of the incident photon, or we can say HF. And the entrance ticket is the work function or the binding energy. This is the work function, W naught or equal to HF naught. Understand? Work function. So your the 100 ticket is 50 ringgit, and you have 100 ringgit in cash. So of course you can pay for the ticket and enjoy the show. Other than enjoy the show, you still have remaining. You still have remaining. This is just right here. This is RM. 100. So the ticket is 50 ringgit. So other than paying for the ticket, you still have remaining 50 ringgit for your snack, your Coke, your popcorns. Okay. So this is what we call the Kmax, the maximum kinetic energy, the remaining energy at the electron. Okay. So what I can say is, the electron will receive all the photon energy. Okay. So we receive all the photon energy, HF. Okay. So if let's say we can say let's say like 10 joule. You see, let's say the incident photon is 10 joule. Okay, so incident photon is 10 joule, and the binding energy is just 5 joule. It's just 5 joule. So you still have remaining 5 joule of energy inside the electron. You understand or not? Because electron absorb all the photon energy, 10 joule, and now the electron has 10 joule of energy to overcome the work function, 5 joule. So it still have remaining 5 joule energy as kinetic energy. Understand? So it's like that lah. Yeah, you have 100 ringgit in cash. Okay, the photon energy, you have 100 ringgit in cash. To overcome the work function, the binding energy, which is the entrance ticket, you pay for the entrance ticket. So you can go to enjoy your show, and you have another remaining 50 ringgit to pay for your snack. The 50 ringgit is like your maximum kinetic energy. Okay. Okay. So we can say, so if the incident photon energy more than the minimum energy, then you can say the electron can be ejected with kinetic energy. Photoelectron ejected with maximum kinetic energy. This one is or we can say the incident frequency more than the threshold frequency, the incident wavelength less than the threshold wavelength. This one we already proven about the frequency and the wavelength. We already proven this one in the previous video. In the previous video, I did derive for you to see why is it the frequency of incident photon must be bigger than the threshold frequency, and the wavelength must be less than the threshold wavelength. I already derived here. Please look back to the previous video about this threshold frequency and threshold wavelength. All right. Okay. Okay. So for the second one, if the energy, the incident photon energy, just enough to overcome the work function, like what I can say is, if let's say the incident energy, HF is the incident energy, just equal to the minimum energy required. This minimum energy is the work function lah. Okay, it's the work function. HF is the incident energy, incident photon energy. If it is just equal to the minimum energy, do you have any kinetic energy left? Or we can say the incident photon frequency equal to the minimum threshold frequency, or the the incident wavelength equal to the maximum threshold wavelength. Okay. Can the electron be ejected? First thing, can the electron be ejected? Yes, because it's just like you have 50 ringgit. Now your mommy only give you 50 ringgit just for you to enjoy the show. So you can just pay the entrance to enjoy the show. You don't have any no more extra cash to buy any snack or what. Okay, so no more kinetic energy. You have 50 ringgit in cash. This is the 50 ringgit in cash. So just enough for you to pay the ticket. So you can enjoy the ticket, enjoy the show, but you don't have extra remaining energy, extra in remaining money to buy any snack. Okay, so yes, the photon just has enough energy to overcome the minimum work function, or we can say the binding energy, but you don't have any remaining energy. The electron don't have any remaining kinetic energy anymore. The kinetic energy is 0. So the photoelectron still can be ejected, but without kinetic energy. So if this kind of electron, if you put inside the 0 voltage, then this electron surely cannot move to the anode. Because it don't have any extra kinetic energy. Like this one, you still have kinetic energy. This one, electron can move on their own to the anode. Understand? This one don't have any extra energy to move on to the anode by their own. Okay? So the first two cases, the electron can be ejected because the HF is more than or equal to the minimum energy required to eject the electron. Or we can say the incident frequency is more than or equal to the minimum required threshold frequency, or the wavelength is less than or equal to the maximum threshold wavelength allowed for the electron to be ejected as photoelectron. Okay, Now for the third one, if the incident energy is less than the minimum energy required, or less than the what we call the work function. If the energy required less than the work function, less than the binding energy, yeah, very small only, very small energy. We can imagine this one is like a big packet of energy. Yeah, this one is like medium size. This one is like very small size. Actually, it's like very small size particle. Yeah, very little energy. So not enough to overcome the binding energy. Yeah, maybe the required binding energy in it is 10 joule, but you only have 5 joule energy. So can you eject the electron? Cannot, because the energy of the incident photon is less than the minimum energy required, or the work function of the electron binded to the metal surface is less than it. So cannot eject the electron. No electron is ejected. Photon does not have enough energy to eject the electron. So electron, although absorb the 5 joule, but that 5 joule will not enough to overcome the 10 joule work function. Understand? So it's just like the ticket is 50 ringgit. The ticket is 50 ringgit, but your mommy only have maybe you misuse the money, yeah, and then you just left with 20 ringgit. Can you enter to the concert? No entry. Okay. So because your 20 ringgit not enough to overcome the work function, 50 ringgit ticket. Understand? So you cannot enter the show because the incident photon has less energy than the minimum energy required, or the work function of the metal surface. Okay. So no electron can be ejected. So this one also happen if the incident frequency less than the minimum threshold frequency, or the incident wavelength more than the maximum threshold wavelength allowed. All these the electron cannot be ejected. Okay. All right, you understand? So to eject the electron, the energy incident photon energy need to be more than, in a nutshell, to eject electron from metal, so the electron need to absorb enough energy to be ejected. Yeah, it need to absorb enough energy to be ejected. The incident photon energy need to be more than or equal to the work function. The frequency of the photon need to be more than or equal to the threshold frequency, more than or equal to the minimum threshold frequency. The wavelength of the photon need to be more than or equal to the minimum, need to be less than or equal to the maximum threshold wavelength allowed. So this one talks about types of light. To eject or not eject, yeah, to eject or not eject, can or cannot, yeah, can or cannot, depends on what? Depends on type of light. Depends on type of light. We can say, I should actually put here. Yeah, this one better. So yeah, actually it depends on type of light. Not all light can eject the electron. Some photon can eject the electron. Some photon don't have enough energy to eject electron. Yeah, because when we're talking about frequency and wavelength, let me write over here. when we're talking about frequency or wavelength of electromagnetic radiation, yeah, we are talking about the type of radiation. The type. Type. Because different frequency, different wavelength, different type. Example I already mentioned in the previous video. Like for example, X-ray has very compare X-ray and radio wave. Yeah, what can you say about their? Okay, and then E equal to HF. Equal to HF. What can you say about the frequency and wavelength? When we're talking a different energy, when we're talking about different energy, different frequency, different wavelength, we are talking about different type of light or different type of radiation. So this frequency and wavelength depends on the type of radiation. So, like for example, X-ray. X-ray has very, very high frequency, very high energy, very low wavelength. Very low wavelength, very small wavelength. When talk about radio wave, have very, very small frequency, very long wavelength, but very low energy. Very low energy. So it is not surprising that like for example, like X-ray, they normally can eject electron. They normally can eject electron because they have the energy more than the work function. Also depend on the work function, depend on the type of metal also. Yeah, it also depend on the to eject the electron for the metal. Also not just depend on the type of light, it also depend on the type of metal. Because the work function, the threshold frequency, threshold wavelength, they are all different type of metal. Depends on type of metal also. Type of metal. Understand? Type of light, type of metal. Okay? So this W0, F0, lambda naught is all depends on type of metal. Different type of metal, different W0, F0 or lambda naught. Different energy of photon, frequency of photon, wavelength of photon, there are different type of light. So depends on, we can say okay. So like this one radio wave, okay, has very low energy. So not surprising, since very low energy, normally it cannot eject electron. Normally, not I'm not saying always. I'm not saying always. Like this one, low energy, normally it has very low energy, it will be less than the work function, so cannot eject the electron. Okay. So what I can say is different type of light, X-ray, radio wave, different type of light has different frequency, different wavelength, different energy of photon. So when we talk about different energy of photon, frequency of photon, wavelength of photon, they are talking different type of light. We're talking a different threshold, different work function, the threshold frequency, threshold wavelength. We are talking about different type of metal. So to eject, can eject electron or cannot eject electron for the metal, it all depends on different type of light. Yeah, you must use the correct type of light, and correct type of metal. How to say it is correct type of light and correct type of metal? This is the condition. The energy of photon need to be more than or equal to the work function. The frequency of the photon, incident photon, need to be more than or equal to the minimum threshold frequency. The incident photon wavelength need to be less than or equal to the maximum threshold wavelength allowed by the metal surface. Okay. So to eject is depend on type of light and also type of metal. Okay, that's it. It does not depend on intensity. Okay, to eject or not eject, one important conclusion is you can say not depend on intensity of light. Not depend on intensity, but it depends on depends on frequency. It depends on frequency. It not depend on intensity. When we talk about intensity, we are not talking about different type of light. Intensity means the brightness of light. It's still the same type of light, but different brightness. Dim light, bright light. Okay, we're talking about brightness. When we talk about frequency, it's different type of light. Different type of light. X-ray, radio wave, red light, blue light, violet light. Those are different frequency of light. Different intensity of light is different brightness of light. Maybe you talk about red light. We have a very dim red light. Maybe very bright red light. We talk maybe I can show one example here. We talk about intensity. Maybe use red color. This is I say this one. You see, this is dim red light. Yeah, and bright red light is this one. This is bright red light. Still red light. Still red light. But different. There, this is a dim red. This is a bright red. This is intensity. You understand, right? This is about intensity of light. About the different frequency of light is different color. We're talking about different color. This is a different frequency is this one. Different frequency is red. And then with blue. This is a red light. This is a different blue light. This is a different intensity. This is different frequency. Okay, different frequency. You see, when we talk about radio, we use different frequency for different channel, isn't it? Different frequency for different channel. But when talk about intensity, it's about you level up the volume or lower down the volume. It's about the loudness of the sound. So see, like that. Okay, so so that's all for this first video. Let's move on to the next one. Yeah, thank you.